When we left off in the last video, we were talking about why do we even care about oxidation numbers? What's the whole point of knowing how to calculate or determine oxidation numbers for atoms and molecules or ions? And one of the ways is oxidation numbers are used to name binary covalent compounds, binary molecular compounds using the Stoch system. And the second reason is because oxidation numbers are really a tool used to take a look and determine if a reaction is an oxidation reduction reaction and to really see what is happening in the oxidation reduction reaction. That's what oxidation numbers help us to do. Along that same lines, oxidation reduction reactions can be some of the most challenging reactions to write and balance. One system of balancing challenging redox reactions is called the half reaction method, and that employs the use of oxidation numbers. Now, in an introductory chemistry class, we're not going to be balancing these types of reactions, but knowing what an oxidation number is and how to calculate it will help you when you go on and take more chemistry in the future. So this portion of our notes on 8-17 note packet deals with looking at closely at what happens in oxidation reduction reactions. Again, nicknamed redox reactions. Let's first of all talk about what oxidation is. Oxidation is defined to be the loss of electrons. If something loses its electrons, its oxidation number would go higher. So something that's undergoing oxidation, its oxidation number will increase because it lost electrons, which are negative. Oxidation is loss of electrons. Sometimes the mnemonic device for remembering that is oil. Oxidation is loss. Reduction is the gain of electrons. If an atom or substance gains electrons, its oxidation number will go down because it's gained something negative. So reduction is gain of electrons. The abbreviation, if we look at the acronym for that, reduction is gain. RIG, R-I-G, reduction is gain. So the device, I can't even say that word. An easy way to remember oxidation is loss and reduction is gain is through the oil rig memory device. So let's take a look at a reaction here. Here we have Fe2O3 reacting with carbon monoxide, and this particular reaction will cause the iron to leave this iron oxide compound, iron 3 oxide compound, and we will produce carbon dioxide. Now, if we look at this type of reaction does not fit any of the 7 types or any of the 6 original types of reactions we've looked at. This is compound plus compound producing element and compound. This does not fit any of the types. This is not single. This is not double. This is not synthesis. This is not decomp. This is not a combustion reaction. This is not an acid-base neutralization reaction. It doesn't fit any of the other types. Well, this happens to be a redox or oxidation reduction reaction. How can we tell? The oxidation numbers of things here have changed. Iron's oxidation number in this particular compound, this is iron 3 oxide. If you uncross it, the iron's 3 plus, the oxide is 2 minus. So iron's oxidation number here, since it's the 3 plus form of iron, it's plus 3. Over here, iron's lost its position in that compound. It is now by itself as an element. So iron over here is 0 as an oxidation number. So as it says down right here, iron starts at plus 3 and it ends up at 0. It went from plus 3 down to 0. The iron was reduced. Take a look at this compound right here, carbon monoxide. Oxygen gets its oxidation number of -2. Carbon would then be assigned a +2. We take a look at this carbon over here in this compound, carbon dioxide. Carbon was +2 over here, and now it goes to +4. Why? It's now with 2 oxygens. The oxygens are -2. 2 times -2 is -4. That means the carbon's +4. So carbon went from +2 up to +4. Its oxidation number increased. It's oxidized. It's said to be oxidized. Here, carbon only has 2 of its electrons being controlled by oxygen. Over here, it has 4 of its electrons being controlled by oxygen. It's lost control of 2 more of its electrons than it had before. Oxidation is loss. Now, iron was reduced. Carbon underwent oxidation. Well, there are 2 other terms that relate to oxidation reduction reactions: oxidizing agent and reducing agent. An oxidizing agent is the substance which oxidizes something else. In this particular reaction right here, iron 3 oxide, the iron was reduced because it oxidized the carbon over here in carbon monoxide. So the substance that itself is reduced is called the oxidizing agent. The oxidizing agent itself is reduced. The reducing agent is the substance that itself was oxidized. Carbon monoxide right here. Carbon monoxide. We're looking at the carbon monoxide on the left. Carbon went from +2 up to +4. The carbon was oxidized. That means carbon monoxide must be the reducing agent. So the substance that has the thing in it that was oxidized, the substance it was in is the reducing agent. Let's take a look at another example here. This is a type of reaction we've had before. This is copper 2 oxide reacting with magnesium. Magnesium is more active than carbon. We learned that in our single displacement activity series. Magnesium is a very active metal. If we have carbon 2 oxide and it's an aqueous solution and we end up with magnesium going into that, magnesium can force its electrons onto the copper and end up becoming 2+. The copper started out at 2+. It ends up going back to neutral when magnesium forces its electrons on it, like active metals are known to do, and copper would precipitate out of solution. This is a single displacement reaction. But oxidation reduction reactions themselves often include a multitude of other types of reactions. The same way that an acid-base neutralization reaction is a specific type of a double displacement, single displacement or replacement reactions are a special type or a special category of oxidation reduction reactions. So what's really happening in this reaction? The copper is 2+. It's with the oxygen, the oxide ion, which is 2-. The magnesium starts out as neutral. We're just kind of looking at the net ionic reaction down in this thing. So copper started out as 2+. Over here, it ends up neutral. Magnesium started out as neutral. Over here, it ends up as 2+. So what happened to the copper? The copper started out as 2+. It was forced to take 2 electrons from the more active magnesium and it ended up back to 0. It went from 2+ to 0. So what happened to its oxidation number? Its oxidation number went from +2 to 0. It went down. The word for being lowered or going down is reduced. Magnesium is an element by itself right here. An element by itself right here is neutral. Its oxidation number is 0. It forced copper to take 2 electrons from it because it's more active. It became 2+. So magnesium's oxidation number went from 0 up to 2+. Why did it happen? Because it lost 2 electrons to copper. Oxygen is loss of electrons. Oxidation is loss of electrons. Oil, oxidation is loss of electrons. Reduction is gain, Rig. So what about our agents there? Well, the copper metal itself was reduced. So copper must be the oxidizing agent. The copper ions are acting as an oxidizing agent. The magnesium itself was oxidized, so the magnesium oxide must be acting as the reducing agent. The magnesium is the reducing agent here. Here's another reaction to take a look at. What is happening here? We have CO2. It's reacting with H2, and we end up with carbon monoxide in water. So what is happening in this reaction right here? Well, hydrogen is an element by itself. An easy way to know that an oxidation-reduction reaction happens is you have an element by itself on one side, and it's in a compound in the next side. If it's by itself and it goes into a compound, its oxidation number has to change. So hydrogen by itself here is 0. Oxygen has left the carbon dioxide and joined the H2 to form water. So hydrogen here is 0. The oxygen here is a -2, which means the hydrogens have to add up to +2. We have 2 hydrogens adding up to +2, so each hydrogen is +1. Hydrogen went from 0 up to +1. Its number increased. It lost control of an electron. Each of these hydrogens lost control of an electron. Oil is loss. The hydrogen was oxidized. Carbon here is with 2 oxygens. It's +4 because 2 oxygens times -2 is -4, so the carbon's +4. Now it's only with oxygen, so it went down to +2. It went from +4 down to +2. Here it was having 4 electrons being hogged. Now it's only having 2 electrons being hogged. Reduction is gain in control of electrons. It went from 4, now it's gained 2 of its controlling back. It was reduced from 4 to 2. What are our agents here? CO2s are oxidizing agents since the carbon was reduced. Since the carbon was reduced, it's the oxidizing agent. Hydrogen here was oxidized, so H2 is the reducing agent. As we mentioned, the very last part of our notes does have the electronegativity table on it, which you may need to consult as we move on and start doing practice problems dealing with oxidation reduction reactions and the determination of oxidation numbers. If you have any questions on these notes whatsoever, or if you have problems or difficulties as we start into the homework, please do not hesitate to email me your questions. I will certainly be happy to help you. We can set up a meet, or we can create additional videos to go over any of these that you might be having trouble with. Thank you and best of luck.